The ArrayList class allows us to create a data structure that functions similarly to how traditional arrays do. There are a few main differences between an array list and a traditional array. The first is that an array list can only contain objects. Primitive data types are unable to be stored in an array list. However, since primitive data types can be represented by objects using wrapper classes, this is not a huge inconvenience. Another difference is that an array list object is dynamically sized, meaning we don't have to initialize it to a specific size. An array list inherits methods from the list interface. We haven't discussed interfaces yet, but we will in a future video. For now, all you need to know is that because the ArrayList class implements the list interface, we are able to use a good amount of methods that are particularly useful when working with arrays. Here is a list of methods commonly used when working with arrays from the list interface. Now let's look at an example using the ArrayList class. First, remember that an array list can only work with objects. So for this example, we will create an array list of string objects. We can do that by typing ArrayList followed by what is called a diamond operator, which is composed of a less than and greater than symbol, aka chevrons. Within the diamond operator, we will put the object type that will be stored in the array list. In this example, we will be working with strings. Next comes the name we will assign to the array list. This array list will hold first names, so we will call it fnames, and we will initialize the array list by setting this equal to new array list with the diamond operators. Within the diamond operators, we'll put string, followed by a set of parentheses. Now, we can leave string here or we can remove it, as it has already been declared here. For efficiency purposes, I'm going to go ahead and remove it, and we'll imagine we saved the time by never typing it in the first place. Now we have effectively created an array list of string objects that we named fnames. Notice we did not initialize this array list object to any specific size, and at this point the array list is empty. In fact, we can go ahead and use the size method to verify this. If we print the size to the console using a print line statement, we can see that it has a size of 0. Let's go ahead and add some names to the array list. We can do so by typing fnames.add, and within the parentheses we will add the name we would like to store in the array list. We'll add the names Bob, Alice, and Jack. Notice if we run the size method on the array list now, 3 is printed to the console as the array list now contains 3 string objects. As with all objects, ArrayList objects also contain a toString method that will allow us to print the contents of the array list. If we go ahead and utilize the toString method, the contents of the fnames array list are printed to the console. Now if you remember in the tutorial in which arrays were introduced, I mentioned that array indexes begin at 0. Therefore, in working with the fnames array list we have created here, Bob has an index of 0, Alice has an index of 1, and Jack has an index of 2. We can verify that by using another method that is inherited from the list interface called indexOf. If we want to check the index of Alice, we can do so by typing indexOf with the string Alice within the parentheses. You can see we get 1 printed to the console. Let's also find the indexes of the 2 other names in this array list. As discussed, we can see that Bob has an index of 0 and Jack has an index of 2. I'll go ahead and add some text to all these print line statements so we know exactly what we are looking at when each print line statement is executed. Okay, now let's go ahead and remove a name from the array list. We will remove Alice. We can do so by typing names.remove with the string Alice within the parentheses. And after we do that, let's go ahead and print the size of the array list, followed by the contents of the array list using the toString method again. You can see the size of the fnames array list is now 2, and the contents are only Bob and Jack. We could have also removed Alice from the array list by typing the index in which Alice was stored in, instead of typing the string Alice in the parentheses of the remove method, and produce the same results as seen here. Now let's go ahead and add Alice back into the array list as well as another name, John, just to prove the point that array lists are indeed dynamically sized. We'll go ahead and print the size of the array list after the addition as well as the contents of the array list after making the additions. Notice the size of the array list is now 4, and the contents now contain Bob and Jack as well as Alice and John. Also notice that Alice is no longer stored in index 1. Instead, Alice is stored in index 2. If we wanted to, we could have put Alice back into index 1 by typing the index in which we wanted to add Alice to when we ran this add statement. When we do so and run the program again, we now have Alice back in index 1 as we originally did. Hopefully you're able to see the benefits of implementing an array list as opposed to a traditional array. In general, unless you are going to be creating a fixed size array of primitive data types, it will likely be the case that an array list will be the better choice between the two when making the decision of which to use in your code.